Here are the solutions for the normal distribution mock exam. Problem number 1. In her math studies IA, Patricia has decided to show that the number of times a student checks their iPhone during a 45-minute class is a normal distribution. So in the space below, sketch this normal distribution with the mean, 12, and the standard deviation, 5, that she found. Okay. So the middle is the mean, and the standard deviation lines, which go out to the left and right, are spaced by 5 because the standard deviation is 5. This would be 24. This would be 2. Oh, not 24, 22. 22. Okay. Another student guesses that the percentage of students who access their iPhone less than 5 times would be at least 20%. Patricia uses the 68, 95, 99 approximation to show why that can't be true for the distribution she found. Please explain. So let's draw the picture. We'll copy this picture. Put it down here. Okay, maybe we'll make it a little smaller. Okay, and then we're going to say, okay, so somebody said that this percentage of people, the people that are down here, who guessed less than 5, or who accessed their phone less than 5 times, is 20%. So let's see, what do you think of that estimate? This person said that this brown area is 20%. Does that look like 20%? Yeah, it could be 20%. But then it says, you know some information about the size of these bands with the 68, 95, 99 approximation, then you can actually verify that 20% to some extent, right? And maybe you don't remember what the 68, 95, 99 approximation is, but if you divide 68 by 2, you get 34, and then it starts to ring a bell, right? You know that these two middle regions are 34%. And you know that this region is 13.5%. And you know that this region is like 2.5%, like going that way it's going to be 0.025%, something like that. Okay, so using that, can we figure out if this is 20% is a good estimation or not? Okay, so we know that this area here is 0.025. And we know that this area here is 0.135. Now, is that 0.2? No, actually 0.2 goes quite a bit further, doesn't it? 0.2 would not only cover this area and this area, that would add up to 16% so far, but also 4% of this area. So it would go further. So that's our explanation, that look, if it was really 20%, it would go all the way past the 7 here. It would be more than 7. It would be around 8 or 9. So that's why that estimate is not a good estimate. Use your GDC to figure out exactly what percentage of students accessed 5 times or less. Okay, then find the expected number of students who access 5 times or less if there are 30 students in the class. Okay, so first we want to know the percentage in the brown area. And we can figure that exactly with our calculator using the distribution, second dist functions. We'll go to normal CDF. We'll put in the region, which the left boundary is negative infinity. The right boundary is 5. The mean is 12. And the standard deviation is 5. Okay. And the answer is 0.0808. And the percentage is 8.08%. Okay. Then find the expected number of students who access 5 times or less if there are 30 students in the class. So we know that it's 8% of the students, and they tell us the total number of students, 30. So we can take 30 and we multiply that by 8% or by the decimal 0.0808, and then we'll get 30 times 0.0808, and we get 2.424. 2.424. And that is the number of students who access 5 times or less. Now, you would either say that that's 2 people, or you would say that's 3 people. You could say, oh, I'm rounding up, or I'm rounding to the closest one. Okay, but you would not say it's 2.4 people, right? So the expected number of people, you would say 2 or 3. I would say 2 because I would round it to the closest one. Okay. Going to the next problem, number 2. The GPAs in 11th grade DAC have a mean of 2.5 and a standard deviation of 0.4. Draw a sketch of the normal distribution with these characteristics. So the middle is 2.45 and the standard deviation 0.4, so this line would be 2.9, this line would be 3.3, this line would be 2.1, this line would be 1.7. Okay. So if we want to give an award to the top 5 students of the 42 total students, what would be the minimum GPA to receive the award? And the hint is to first figure out the percentage of 5 students out of 42, then to shade that percentage in the diagram here. So let's take 5 students divided by 42. On the calculator, we get that it's 0.119 or 11.9%. And then we're going to shade it on the diagram. Where exactly do we shade this 11.9% on the diagram? Is it here, here, here? Let's say we shade it here. Does that make sense? 11.9% of the people here? Well, it would, except for it's the top 5 students, and these students are getting like a 1.7 GPA, so that's not right, right? We want our top 5 students to be up here, getting the 3.0 GPA, right? Okay, and then the question is, like, if this is actually 11.9%, then where exactly is this line here that divides the brown region students to the transparent region students? Well, we can figure that out with the calculator because we know some critical values. We know that it's 11.9% of the area. We know that the mean is 2.5, and we know that the standard deviation is 0.4. So if we give all that information to the calculator, it can figure out where this brown line exactly is. Now, there's just one thing about the calculator. It's expecting you to give the region to the left of this brown line, not to the right. So we cannot give it 0.119. We need to give it 1 minus 0.119. We can't give it 11.9%. We have to give it 88.1%. Okay, so let's give the calculator that, and the function is called inverse normal. So we turn it on, and we do inverse normal.